Okay, so we are proceeding with question number 6B, and the question tells us by using a sketch, we have to find a reflection of a given point A, which is 2, 3, and it is reflected in a plane of y is equal to x, right? But it is followed by another reflection in a plane of y is equal to negative x. That is another reflection. So this means that it is going to be reflected twice. That is double reflection, right? So in a given scenario, we have first to sketch and know where do we find a line which is exactly y is equal to x. So how do we draw such a line? Such a line is being drawn by locating 1 here and 1 here. So you have point 1 here, 1 there, 2 there, and another 2 here. So the value of y and x are equal. That is what it is meant by y is equal to x. That is the value of the y-axis. If it is 1 here and here it is 1, so you locate that point. 2, 2, 3, 3, and so forth. Likewise, -1, -1, -2, -2, it is there. Then so forth, coming down until infinity. So you join the points and you are going to obtain the plane or a line which is y is equal to x. Okay, so after obtaining such a line, what we have to do is to locate our point A, which is 2, 3. So 2 here and 3 here. So this is 2, 3. So the point A is there. So how do we find the image of the first reflection? So if this is our mirror, we expect that the image is going to be formed behind the mirror, right? The reflection, you remember the reflection. So the image of this is going to be obtained behind the mirror. But remember, the image is going to be perpendicular to the mirror surface. So if I draw a perpendicular line in the same distance from this point to the other point, where is it going to fall? I think it's going to fall at x is equal to 3 and y is equal to 2. So a point A dash is going to be 3, 2. So actually, from this, you can just infer that if you have a reflection in a point along the line y is equal to x, it is just the reverse of your points. That is, the value of y is going to be the x and the value of y. The x is going to be y, so it is going to be 3, 2. That is the point of reflection in y is equal to x plane, right? After that, we have to find now the reflection of this point. This point is again reflected in a line of y is equal to -x. Now, that line y is equal to -x, it is the vice versa of this line. If this passed at these quadrants, the quadrant 1 and quadrant 3, so the other line y is equal to -x is going to pass in a quadrant 2 and quadrant 4. So this is going to be likewise. We have here, so we have to locate the points again because it is y equal to -x. So the value of y is positive, the value of x are negative. So it is there. Here likewise we have one of them negative there and there. So we can join these points so that we can obtain our line. Join the points like that, and I can try to wrap these lines so that I have my line there, and I have my line here, a line y is equal to -x. Now, remember my point is here, right? Here is my point, and the reflection is actually gonna be the same distance but perpendicular now to this plane, y is equal to -x. So we draw a perpendicular line to our plane, that is from this distance to the plane should be equal from this point backward. The same distance from here to here to here to here. So it is going to fall along where x is equal to -2 and y is equal to -3. So this is A double dash. This was A dash and this is A double dash. That is the reflection of the second point. So what does this mean? If you clearly observe in a reflection of y is equal to -x, y is equal to -x is actually the reverse of this. The y comes to x and x comes to y, so it is going to be 2, 3, but all negative. That is what we obtained here, -2, -3. So at last what we obtain? At last we obtain the reflection. Now say therefore, the reflected point will be A double dash, which is -2, -3. So after the double reflection, the first reflection of y is equal to x and followed by a reflection on a plane of y is equal to -x, now we are going to obtain point this is reflected until it becomes -2, -3, and that's all.